and welcome to the video that's going to be covering the area of trapezoids in 3 different ways. So some examples of trapezoids that you'll see in the real world here are this table, this window, this bridge, and this plane wing. So this is a shape that, even though it is slightly different than some of the other methods we've been doing and some of the other quadrilaterals we've been doing, it is a very real world skill that we're about to cover today. So let's just start with the definition of a trapezoid to make sure we're all talking about the same thing. So the way that I define a trapezoid is a special type of quadrilateral, and quad means 4, so a 4-sided object where 2 sides are parallel to each other. Most quadrilaterals you'll see are going to be like this, where you have a base and another base that are parallel to each other. That's what this symbol means right here, but they are not equal. And then on the edges you have the leg and the leg. Okay, but you can also have trapezoids that look like this on the side, where you end up creating right angles. These sides are still parallel to each other, and these other sides are still not. And finally, you can see some like this as well. It's very similar to one on the left, except that it is tipped on its side a little bit. But as you notice, frequently in a trapezoid, other than 2 pairs of or 2 sides being parallel to each other, you usually don't have a lot of other information. Many sides are not equal to each other. The bases are not always equal. The legs are not always equal. So they can be a little tricky to get used to. So the first way that we can find the area of a trapezoid, and I call this strategy splitting into 3 separate shapes. If you notice a trapezoid, usually with the edge here, you end up creating a triangle, a rectangle, and another triangle. Okay? In order to do this method, you have to know the direct height. So this would have to make a 90-degree angle, which it does in this case. And you need to know the lengths of both bases. Because both bases are given to us, we can actually erase the longer one for now. And we can treat this bottom base as 6 inches as well. Which means the middle part has an area of 6 times 4, or 24 square inches. And this would be the middle rectangle. Now, if we do the strategy the way I'm doing it, each triangle left on the outside should still be equal to each other, okay? But if we know that the total length was originally 10 inches and the middle is 6 inches, that means we have 4 inches left over. And we want to make each of these the same, which would make them each 2 inches long. Okay? 2 plus 6 plus 2 is still equal to 10, so this works. And we can now find the area of each rectangle. Or triangle, sorry. So finding the area of each triangle on the outsides. So 2 times 4 is 8, but a triangle is half of a rectangle, making this 4 square inches. And this one over here, same thing. 2 times 4 is 8 divided by 2 gives us 4 square inches again. Giving us our total area of 24 plus 4 plus 4, which is 32 square inches. So that is strategy 1, splitting into 3 separate shapes. Strategy 2 is turning the trapezoid into a rectangle. This is the one my wife, when she taught math, loved showing her students, because if you understand the strategy, it is really, really fast. So I want you to look at each of these triangles here on the outside. So I have one that's right over here, okay? If I wanted to kind of cut it out a little bit just so it's easier to see, the triangle is right there, okay? I want you to think about taking this triangle and moving it over to the opposite side of the trapezoid. Now, when I do that, I would have to be able to flip, which I can't do on this program. So I grabbed another triangle for us here on the right. Oh, it's not letting me drag There we go. So I grab the other triangle right here, and it should line up really nicely if we did everything right. Then I want you to imagine we were able to cut and remove this triangle out here. So this one is gone. And what you see is we have now created a rectangle. And the area of a rectangle is actually a lot faster to find than the area of a trapezoid. So I need to figure out what this new length is up here on the top. So the length from here to here. Okay, well, we know from the last problem that this piece here was 2 inches long. And we cut that piece out, and over here it does not have 2 inches for the length. Meaning the new base length has to be 6 inches plus the extra 2. Which means the base has an area, or the length, of 8 inches. And now the area of a rectangle is simply base times height, which gives us 32 square inches, which was the same area that we got on the last problem, and it should be, because these strategies should give us mathematically the same answer. Okay, so now there is one method left, and if you look it up online, this is the one you're going to see most often, which is the traditional algorithm. Okay, so an algorithm is just a series of steps, and you're frequently going to see the algorithm is going to be written something like this: base 1 plus base 2 divided by 2 times height. And I think that's a really confusing way to write that, so I have a different way that I write it. I write, it is the average of the bases times the height. A little bit easier to remember. It's just the average of the bases times the height. So our bases in this problem are 6 and 10. So to figure out the average of the bases, I'm simply going to do 6 plus 10 divided by 2. Or I could think, what number is halfway between 6 and 10? Well, both ways is going to give me the same answer. It's going to be 8 inches. And then I simply do the average of the bases, which is 8, times the height, which was given to me as 4. And I get, once again, the same answer a third way, 32 square inches. Now, I want you to notice really quickly why the traditional algorithm works really nicely. So when we're doing the average of the bases, we're going halfway between our two base numbers. But on the last problem, when we're cutting out this rectangle or triangle and moving it over, we're actually doing the same thing. This number right here is actually always going to be the average of your bases. So you're going to eventually get the same answer all three ways. So as a quick review, the three methods of finding the area of a trapezoid: you can split it into three shapes: triangle, rectangle, triangle, or sometimes just triangle, rectangle. Turning the trapezoid into a rectangle, that was the second one. And then the final one is the traditional algorithm, which is the average of the bases times the height. As always, if you have any questions, make sure you let me know.